Hello guys, and welcome to this lesson. In our previous lessons, we started a wonderful job on circular motion. We worked on the introduction into circular motion. Then we went on to derive, the formulas for angular and linear displacement and velocity. So today we are looking at how we're going to derive the formula for angular and linear acceleration. So now when we talk about angular and linear acceleration, what are we talking about? Don't forget, we talk about angular and linear acceleration. Acceleration is simply the change in velocity over time taken. So let's see how we're going to derive the formula for linear and angular acceleration. So right here we have a circle like this. Let's assume that there's a ball. Maybe a ball. Let's say a ball is being weird. Now this is a string. Let me say this is a string. Now the ball is here at point A. Now the ball rotates like this, gets to point B also like this at this angle theta. So the ball is here at this very point. Then the ball rotates down to the very point. Now, at the very point, don't forget that in our previous lesson we said at this very point, this ball has a velocity of v, let's say v. Then at point B, there's another velocity of this at point B. Now, don't forget that this is a uniform circular motion, and also we can say it's horizontal, motion. So now the fact is this: you also have an angular velocity, a velocity that is concerned about the angular movement of the very body. While this one talks about the speed of the very body at different junctions, at junction A and junction B. So how do we derive the formula for linear and angular acceleration? Now there's it. For linear acceleration, now let's start with angular acceleration first. Now for angular acceleration, angular acceleration is being denoted. We're going to see what we're going to use. We're going to use alpha to denote it. Angular acceleration, which I'm going to use alpha for. Angular acceleration is simply the change or delta. Anyhow, I use delta to represent change. Is simply the change in angular velocity, angular velocity over time taken. It's simply the change in angular velocity over time taken. That is what angular acceleration simply is. So when we talk about angular acceleration, now don't forget we're using alpha. So what's the change in angular velocity? Angular velocity is simply this omega over time taken. So now this angular velocity is in rad per second, that's radians per second. In our previous lesson we derived this and we got the very unit. While time is in seconds. So it means angular acceleration is in rad